Hello friends, myself R.D. Mahajan presenting my video on beta gamma function. Let us see the problem. Evaluate integral from 0 to infinity root y into e raised to minus y square and its integration with respect to y, and second integral into 0 to integral from 0 to infinity e raised to minus y square divided by root y dy. And to obtain the value, we try to convert both the integrals in the form of a gamma function, as it involves the term of e raised to minus y square. And therefore, let's consider that integral as I. The first one we call as I1 and the second one is called as I2. This is equation number 1, where I1 is integration from 0 to infinity root y e raised to minus y square dy. And then we try to convert it in the form of definition of gamma function. We know the definition of gamma function. Gamma n is integration from 0 to infinity e raised to minus x, x raised to some n minus 1, and its integration with respect to x. That is called as a gamma function. And therefore, to convert into this form, we substitute, we call this equation 2, put y square as some t, differentiating it with respect to y, we get 2y dy is equals to dt. Taking square root, we get y is equals to, it implies y is equals to root t, and therefore dy is equals to dt divided by 2y, y is root t. And then new limits for y equal to 0, we get t is equal to, when we put y equal to 0 here, we get t equal to 0, and when we put y equal to infinity, we get t is equals to infinity. Substituting this information in equation 2, that equation 2 becomes I1 is equals to limits remain same 0 to infinity root of y means the square root of this term, and therefore it becomes root t and its square root, therefore it is raised to 1 by 2 e raised to minus y square is t, therefore it becomes e raised to minus t, and the value of dy is dt divided by 2 root t. It is equals to 1 by 2, I can take outside, integration from 0 to infinity e raised to minus t as it is, no change. Combining the terms of t, this becomes t raised to 1 by 4, and transferring this root t to numerator, it becomes t raised to minus 1 by 2, and then its integration with respect to t. Therefore, it is equals to 1 by 2 integration from 0 to infinity e raised to minus t raised to 1 by 4 minus 1 by 2, finding LCM. LCM is here 4. 1 minus 2, we get minus 1 by 4, and then its integration with respect to t. Rewriting this term in the form of x raised to n minus 1 by adding and subtracting 1 here. Therefore, I will add 1 here and subtract 1, so that no change in the value of that integral, only I am changing the form, and therefore it becomes 1 by 2 integral from 0 to infinity e raised to minus t and t raised to this is 4 minus 1, that is 3 by 4 minus 1, and its integration with respect to t. Comparing this with this form, it is gamma n, here n is 3 by 4, and therefore it becomes 1 by 2 gamma of 3 by 4. We call this equation 3. This is the value of that first integral I1, obtained by converting it in the form of definition of gamma function. By using this substitution, we get that value as 1 by 2 gamma 3 by 4. Similarly, we try to find out the value for the second integral with the same substitution. And we consider the second integral as I2, integration from 0 to infinity e raised to minus y square divided by root y, and its integration with respect to y. And then to convert in the form of gamma, we use the same substitution, y square as t, taking square root we get y is equal to root t, differentiating it we get 2y dy equals to dt, therefore dy is equals to dt divided by 2 root t, and the new limits for y equal to 0 we get t equal to 0, and for y equal to infinity we get t equals to infinity. Limit remains the same. And then using this substitution in equation 4, that equation 4 becomes I2 is equals to 0 to infinity e raised to minus t divided by root y. Root y means root t raised to 1 by 2, and the value of dy is dt divided by 2 root t. Simplifying it, we get 1 by 2 as it is taken outside, integration from 0 to infinity e raised to minus t and t raised to, combining the power, it is 1 by 4 minus 1 by 4 and minus 1 by 2, and its integration with respect to t. And therefore, it becomes 1 by 2 integration from 0 to infinity e raised to minus t as it is, no change. Finding LCM once again, 4 is the LCM, minus 1 minus 2, we get minus 3 by 4. T raised to minus 3 by 4, and its integration with respect to t. Here also, we try to convert this in the form of x raised to n minus 1 by adding 1 and subtracting 1. Therefore, if we add 1 here and subtract 1, so that no change in the value, we have the new form. It is 1 by 2 integration from 0 to infinity e raised to minus t, t raised to 4 minus 3, we get 1 by 4 minus 1, and its integration with respect to t. And then comparing this with this result, it is nothing but gamma n. Here the value of n is 1 by 4, and therefore it becomes 1 by 2 gamma of 1 by 4. We call this equation 5th. Therefore, substituting the values of I1 and I2 in equation 1, we get substituting the values of I1 and I2 in equation 1, that equation 1 becomes I is 1 by 2, value of I1 is 1 by 2 gamma 3 by 4, and value of I2 is 1 by 2 gamma of 1 by 4. Therefore, it becomes 1 by 4 into gamma 1 by 4 gamma 3 by 4. And to find the value of this type of product of two gammas, we try to apply a duplication formula. By duplication formula, we have gamma n into gamma 1 minus n is pi divided by sin n pi, when n lies between 0 to 1. Therefore, applying this result here, we consider the first one as n. Therefore, here n is equals to 1 by 4. 1 minus n becomes 1 minus 1 by 4. 4 minus 1, it becomes 3 by 4. 1 by 4 is in between 0 and 1. And therefore, applying that result, we get here 1 by 4 pi upon sin n pi. The value of n is here 1 by 4 divided by pi, means it becomes sin of pi by 4. And using this standard value of sin pi by 4, it is 1 by root 2. That becomes pi divided by 1 by root 2. And therefore, it is root 2 pi. 4 means root 2 square. Root 2 into root 2 we get 2 and its square. One root 2 get cancelled and the remaining term is pi divided by root 2 into root 2 into root 2. That becomes 2 root 2 as the value or the final answer for that product of two definite integrals. Here two important things. One is the conversion in terms of gamma function, and after converting it we get this term 1 by 4 gamma 1 by 4 into gamma 3 by 4, and to find the value of this two gammas, a product of two gammas, we apply this duplication formula, which already I have discussed in my previous video. I will provide the link for that video in the description. Therefore, the value is pi divided by 2 root 2. One more I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to receive notification for my new videos, all new videos. For that you have to press the bell icon. Thank you.